Hi everyone. We are going to work on these problems here for the Test 10 practice. And the first one, I have an application problem here. When an airplane leaves the runway, its angle of climb is 18 degrees and its speed is 275 feet per second. So I want to get a feel for this. I want to draw this. So it's going down the runway, and then it leaves the runway at an 18-degree angle. All right. And it says find the plane's altitude after 1 minute. It's going 275 feet per second. So it goes 275 feet per second. And if I multiply that by 60 seconds per minute, I will find out how far it travels in a minute. And 275 times 60 is what will give me that. 16,500 feet per minute. So in 1 minute it goes 16,500 feet. So that is my hypotenuse here. And here is the altitude here. And it looks like the altitude is opposite the 18-degree angle, and 16,500 is the hypotenuse. So I am going to use the sine of 18 degrees, set that equal to the opposite side, which is A, over 16,500. So I will multiply both sides by 16,500. And okay, that doesn't look like a real reasonable answer. And my first check is that is it in degrees, and it is not. So now let's do that. 16,500 times sine of 18. I'm looking at 5,098.8 feet. So that's very, very close to a mile. Takes it a minute to go a mile up. Okay. Number 2. Find a model for simple harmonic motion. So is it going to be D equals A sine WT, or is it going to be D equals A cosine WT? Okay. The displacement at is 0 at t equals 0. So as it goes up and down, it starts at the origin, and that looks like a sine one for me. So D equals, the amplitude is A, so let's put 7 here, then the sine, and then got to figure out W. Well, the period is 2 pi over W, which is 3 seconds. Equals 2 pi over W. I'm going to multiply both sides by W. And I have 3W equals 2 pi, and then divide by 3. And W is equal to 2 pi over 3. So I'm going to put 2 pi over 3 times T right there. And I think I got my model for that one. On this one, the displacement is 4. If this is 4 right here, at t equals 0. This is where t is 0. And then, so that's this model more. And that looks like a cosine. So D is equal to A which is 5 inches here, times the cosine, and then w, the period is 2 pi over w, so 2 pi over w is 2.5 in this one, seconds. And if I multiply by w, I got 2 pi equals 2.5 w. And I'll divide by 2.5. And w is equal to 2 pi over 2.5. And I'm going to double that because I don't want a decimal down there. So I'm going to make this 4 pi over 5. That's where I'm putting w. And I'll put t right there. All right, number 4. For the simple harmonic motion described by d equals 1/4 cosine 12 pi t, give the following. The maximum displacement, that's what a is 1/4 of a unit. The frequency, it is w over 2 pi. Frequency is the reciprocal of the period. And in this case, we're going to take w, which is 12 pi. That's what that coefficient of t is right there. Put it over 2 pi. Looks like 12 divided by 2. It looks like it's 6 cycles per second. Now the value of d when t is 6. So d is equal to 1/4 times the cosine of 12 times pi times 6. And do keep that group together. And that's 1/4 times the cosine of 72 pi. And that's a lot, but that is a multiple of 2. That's going to be the same as it is at 2 pi. And I think if you go through that, and if I was using this, I'd change it back to radians. But this is going to be 1. So it's 1/4 times 1, so it's 1/4 of a unit after 6 seconds. And what's the least positive value of t when d is 0? So it is a cosine function. The period is 2 pi over 12 pi, which is 1/6. The period is 1/6 of a second. Half the period is 1/12 of a second. Half of that, the least positive value of t, is the least value. This is t. This is d. This is a 1/4 right here in case you're interested. Half of a 12th is 1/24. So it's 1/24 of a second is the first time d gets to the equilibrium place. Okay. All right, 5 through 8. Now you will have your unit circle if you wish. Arc sine of 3 pi over 2. Now I do want you to recall, and where's the sine? It'll be positive. 3 pi over 2 be right up here, and that is at pi over 3. And that is within our range that we have for sine. Now I have radical 3 over 3. Tangent is in the same place. So I know we got to be in the first quadrant here because it's positive. Sine over cosine here would be negative. Now, if I take radical 3 over 2 and put that over 1/2, that's going to equal radical 3. So I'm going to need it the other way around. I need the 1/2, which is the sine, to be over the square root of 3 over 2. And I believe you can go through and simplify that. We've done that a bunch, though, that's going to be that when it's simplified, when the denominator is made rational. So this is the y, the 1/2, and this is the x. So So I think we're right here, and that is pi over 6, I think, when you look at your unit circle. Now, this one might seem fairly straightforward. Again, we work in just those two quadrants. And the arctan of the tangent of 11 pi over 6. Well, 11 pi over 6 is right there if we go in the positive direction. But our range is negative pi over 2 to positive pi over 2. And this is 0 here. And because of that, we won't use 11 pi over 6. That's not part of the range. We use the negative pi over 6 here. So that is how we just rewrite that, converting that to that angle. All right, and then the secant of the arctan of 3/5. Now, the tangent, well, let me just draw that. If I draw a triangle and put theta here, and it's the angle that has the opposite side of 3 and the adjacent side of 5, and I'm going to take 3 squared plus 5 squared and get this r squared, which is 9 and 25. That's 34 equals r squared. So this is the square root of 34 here. All right. Now secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. Secant then would be hypotenuse, which is the square root of 34, over adjacent, which is 5. Okay. Now, I'm going to keep moving through this. We are solving equations here. Sine of x equals the square root of 3 minus sine of x. And this one has an interval designated. If they don't, we use the n2 pi or n pi thing, whatever is appropriate there. So I'm going to add sine of x here and here. Get the sine of x on one side. So that is 2 times the sine of x equals square root of 3. That canceled. Then divide by 2. I got the sine of x equals the square root of 3 over 2. Now in our unit circle, where is sine positive? Radical 3 over 2. Be like right here at pi over 3. And be like right here, let's see, at 2 pi over 3, I believe. So x is equal to pi over 3 plus 2 pi n. We could keep going laps around there. Or x is equal to 2 pi over 3 plus 2, that's an n, pi n. All right? And let me divide this one by 2. I have the sine of 2x equals radical 2 over 2. Now, we are solving for 2x right now. Where's the sign positive? Here and here. It looks like at pi over 4 and 3 pi over 4. So 2x is equal to pi over 4 plus 2 pi n, or 2x is equal to 3 pi over 4 plus 2 pi n. And I'm going to what I'm actually going to do is take half of both sides so that I just have x. I'll take half of this side. Half pi over 4, that's pi over 8. 2 times 1/2, that's 1, so plus pi times n. And take half of both sides on this side also. And we're looking at the other value of x that we could have is x equals 3 pi over 8 plus, and for the same reason, pi n. So there's our two, get those n's included there, answers. Now, we have the n and the 2 pi's and all that involved here. When we have a designated, we're not going to do that. We're just going to find everything in that area. So I've got 2 cosine squared x minus cosine x. I'm going to subtract 1 from both sides. Minus 1 equals 0. All right, I'm going to do something, and instead of using cosine, I'm using u. I'm looking at 2u squared minus u minus 1 equals 0. So I'm just trying to factor that. I'm not even going to do that part of it. I just want to factor this polynomial so that, and then transfer it over here so that it'll make it easier to solve. Okay, I got negative 1 times 2. I need something that multiplies to negative 2 and adds, the coefficient here is negative 1. And it appears to me that if I take negative 2 times positive 1, negative 2 times positive 1 is negative 2. Negative 2 plus negative 1 is negative 1. So my factoring next step would be 2u squared minus 2u plus 1u minus 1. This is just how we're splitting up this middle term, negative u, in this way. That's what this helps me do. So that we can factor by grouping. 2 and u are common factors there. I need u, one more u for u squared, minus 1. 2u times negative 1 gives you negative 2u, plus 1 times u minus 1. And I'll put those two together. That's 2u plus 1 times u minus 1. Now I'm just using that. Now instead of the u's, let's put the cosines in. So 2 cosine x plus 1, using cosine x instead of u, and cosine x minus 1 here equals 0. Now we've got 2 to solve. 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. So, I subtract 1, get 2 cosine x equals negative 1. I divide by 2. Cosine of x equals negative 1/2. All right. Negative 1/2 cosine. That would happen, let's see, here, and I think up here. And that's pretty close to that. So that's the 2 pi over 3 here. 3 pi over 3. I think we go 4 pi over 3 here. So those are two of the solutions. That's what goes with x on that part. Now if I add 1 to both sides, I've got cosine of x equals 1. And where's the cosine 1? I think right there. And it's 0 to 2 pi. 2 pi would not be a solution because that's got the curve bracket. So we would go with the 0 here instead of the 2 pi here. So we are looking at 0, 2 pi over 3, and 4 pi over 3. All right. And now find the exact values. All right. I will be right back. Okay. I think we're back in business here. 75 degrees. Two numbers that are on your unit circle are 30 degrees and 45 degrees. So we're going to use the angle sum. And the angle sum for sine is sine of u. I'm just going to go ahead and write that. Sine of u plus v equals sine u cosine v plus cosine u sine v. All right, so I got to go sine 30 degrees cosine 45 degrees plus cosine 30 degrees sine, 45 degrees. Okay, separation there. Sine of 30 degrees is 1/2. Cosine of 45 degrees is radical 2 over 2. Cosine of 30 degrees is radical 3 over 2. And sine of 45 degrees is radical 2 over 2. And then that's the square root of 2 over 4. And then that's the square root of 6 over 4 in one fraction, which would be nice and required. Square root of 2 plus square root of 6 over 4. All right, now how to make negative 285. Be looking at your unit circle. There's ways of going about it. I think I want to use a subtraction. I wonder if I can use a 30-degree angle. Minus something equals negative 285. So if I subtract 30, I got negative x equals negative, 315. 315's on our thing, right? Okay, so I'm just playing around a little bit, and I'm saying cosine of 30 degrees minus 315 degrees gives me the negative 285 degrees. And the cosine difference is, I'll write that over here, cosine of u minus v equals cosine u cosine v minus, plus sine u sine v. So I'm going to take the cosine of 30 degrees times the cosine of 315 degrees plus the sine of 30 degrees times the sine of 315 degrees. Okay, let me get that kind of pictured on the circle. There's cosine of 30. So that's the square root of 3 over 2. And the sine is 1/2 here. 315, 270, that's 45.